Okay, last little bit of gas laws. Lussacs law is our last one. It's talking about pressure and temperature. These also have a direct relationship, meaning they change in the same direction. Same direction, direct relationship. So as the temperature drops in this one, the pressure also decreases. Or as the temperature goes up, the pressure increases. The formula for this one's going to look a lot like the last one we did. Again, missing the ones, whoops. Pressure 1 over temperature 1 equals pressure 2 over temperature 2. You should really get 3 of the 4 variables and solve for the last one. Again, temperature must be in Kelvin always. Okay, here's a quick one. Should work just like the same as the lessons we did with the math at least. Note temperature in Kelvin, so you're good. Pause it, solve it, see what you get for temperature 2. See if you can estimate which one you think it is just by how the numbers should go with the direct relationship. Okay, now you're back. Hopefully you got an answer of 10,927 Kelvin. Like, what? That went up a lot. It did, but oh my goodness, look at this pressure jump. Pressure went up almost 40 times as much, so the temperature should go up a lot as well. Okay, so let's just talk in general terms. If we take a balloon outside on a cold day, what happens to it? Pause, think about it, get an answer, and let's see if we agree. So, it should shrink. Aww. Why? Well, this is the part where kinetic molecular theory ties in really well. Why is that balloon becoming smaller? It's not losing any particles. The balloon's not losing the helium or whatever gas you have in there. Balloon stays inflated normally because the gas molecules on the inside are bouncing around, putting pressure on the outside of the balloon. So if this is my balloon, there are little particles bouncing around here. They're hitting the outside walls, putting pressure on that outside of this thing. But when we take it outside, the speed of these particles gets colder. And when they get colder, they start moving slower and slower. And so they're not moving as quickly. So they're putting less pressure on here, meaning the pressure on the inside is less. But the outside air pressure is still about the atmospheric pressure. It does not change. So it's still pushing in hard on this balloon, making it have more force on the outside than on the inside until it's evened out by making it smaller. If this is a smaller amount, then they are still bouncing around with enough speed and enough of them to even out the pressure and make it stable again at a smaller size than it was before. Hopefully that makes sense. If not, ask questions.